Hello everyone. So we're going to get started with our next unit, which is all about right triangles and trigonometry. So we've been talking about triangles a lot lately, whether we're trying to prove that they're congruent or similar, maybe classifying the triangles. And one thing about this unit that's different is that all the triangles are going to be right triangles, which is when we see a right angle in the triangle. So they should look like this. And one theorem that is really important to this unit, and remember theorem is just another word for like a rule in math, is called the Pythagorean theorem. And whenever we see right triangles, we can label the sides like A, B, and then the diagonal side is C. And I'm not sure if you remember, we've talked about these terms before, but we're going to talk about them more now. So this theorem can be used to find the missing side of a right triangle. Sides A and B are called legs. And then side C, which is like the one that has a slant to it, or the diagonal side, is called the hypotenuse. And for any right triangle, this is what the Pythagorean theorem says. A squared plus B squared equals C squared. So to apply this, if we're told to find the value of x, round our answer to the nearest tenth, we can start by saying, okay, this is our A, this is our B, and this is our C. So since A squared plus B squared equals C squared is like our formula, we just need to plug in these numbers into that. So I would say 8 squared plus 13 squared equals C squared. Then we just need to simplify. Well, 8 squared is just basically asking what's 8 times 8. That's 64. 13 squared is 169. And then we still have C squared over on the left, or on the right. 64 plus 169 would give us 233. And we need to know what C is. And so we need to solve for C or get it by itself. And the way we can do that is by canceling out this squared. And if we think about, well, when we see like 2x equals 10, we divide because 2 and x are being multiplied and division is the opposite of multiplication. So if we're talking about squaring our variable, the opposite of squaring something is taking the square root of it. So what we need to do is draw a little square root symbol because that square root is going to cancel out our squaring. And then let's do the same thing to the other side. So our C, or I guess I could have written an x here, is the square root of 233, which you would just have to type that into your calculator and round that to the nearest tenth, which means one spot after the decimal. That would be 15.3. So that's how we're going to do all the problems that we're about to see. We're given, on number 2, we're given a couple of legs. So let's say 27 squared plus 22 squared equals x squared, because x is our hypotenuse in this case. So let's go ahead and simplify this. 27 squared is 729, and then 22 squared is 484. You could find those easily by just typing that into the calculator. That is equal to x squared. Then let's combine these. So 484 plus 729 is 1,213. And then to solve for x, we just need to get rid of the squaring by taking the square root of both sides. And then x is by itself, and we just need to type in our calculator the square root of 1,1213, which is 34.8. So those are our answers there. Let's look at number 3. Our variable now is one of the legs. So instead of writing it like we saw before, we're now going to do something like this. 7 squared plus x squared, because that's one of our legs. And then the 9 squared, since that's the hypotenuse, that always needs to go on the other side by itself, and it's also going to be squared. So 7 squared, that's like asking what's 7 times 7, 49. We can leave x squared how it is. And then 9 squared, what's 9 times 9? That's 81. And we need to move some stuff around in order to get x by itself. So I need to move this 49 over to the other side. This is just like basic algebra stuff. I'm going to bring this x squared down. And if I take 81 minus 49, that should give me 32. And then I square root to get the x by itself. So the square root of 32 is 5.7, which means that's my answer. That's what this side length would be. Okay, so number 4 is pretty much the same concept. We have a leg that we need to solve for. So we can take 19.1 squared plus x squared equals 30.5 squared. And let's go ahead and do some simplifying. So 19.1 squared would give me 364.81. And then 30.5 squared would give me 930.25. So again, I need to move this over to the other side so that my x can be by itself on the left. So let's subtract that since it's a positive number. X squared is equal to, once I do that subtraction, you could do this manually if you like, or you could just type that in the calculator. That's going to be 565.44. Then I just need to take the square root of that. So x is equal to, in this case, it's going to be 23.8. All right, so number 5 might look a little bit different, but essentially what we're seeing is this is a right triangle right there. And then there's also a right triangle on the left. So if we know that this side on the left is 24, we can tell that this is right in the middle. So if I want to know what this side is, I just need to take 22 divided by 2, which would be 11. So what I really am dealing with is a triangle that has 11, x, and 24 as their sides. So I can say 11 squared plus x squared equals 24 squared. So 11 squared is 121. 24 squared is 576. Let's go ahead and solve for x by just doing some algebra. 576 minus 121 is 455. And then I can square root that. That would be 21.3. So that's what this side would measure, 21.3. Okay, let's look at number 6. This, when we look at it, doesn't seem like a right triangle, but if we draw a line like right here, there's our right triangle. And we know that this is x because it's the same height right there. And we need to know what this side is. If we know that this whole thing is 18 and this section is 5, we can just subtract these two. 18 minus 5 is 13. So those are the sides that we're going to use, 13, 16, and x. So now what we can do is say 13 squared plus x squared equals 16 squared. So 13 squared is 169. 16 squared is 256. Let's go ahead and subtract this 169. That's going to be 87. And then let's square root that. So the square root of 87 rounds to 9.3, which means that's the answer. So number 7 is also getting a little bit more complicated because we essentially have two right triangles. We have one here on the left, and then we have another one here on the right. And if we want to know this whole side, we need to know what this side is, and we need to know what this side is, and then we can just add those two numbers together, and that would be the whole bottom side. So what I can say is that this can be like our A. So I'm going to write a squared plus 12 squared equals 14 squared. I'm just applying Pythagorean theorem to this triangle on the left. And now I can solve this for A. So 12 squared is 144, and 14 squared is 196. I can subtract to simplify. 196 minus 144 would be 52. And then I can square root that. So A is about 7.2. And now I can treat this other leg over here as like my B. So I'm now going to apply the Pythagorean theorem to the triangle on the right, which means I can write something like 12 squared plus B squared equals 29 squared. So 12 squared is 144. Let's leave that B squared how it is. 29 squared is 841. And now let's do some algebra to find out what B is. This is going to simplify to 697. And then once I square root that, B is about 26.4. So to find x, I need to add my a and b. So 7.2 plus 26.4, that is 33.6. So that would be the answer there. It's kind of a more complicated problem. And it's just gonna keep ramping up. So number 8, we also are looking at two different right triangles, and we want to know what this side is, but we don't know what this leg is. So if we want to use the Pythagorean theorem on this triangle, we need to know at least one of the legs. So we can use this Pythagorean or this triangle on the bottom to find the leg that is like the shared side of these two triangles. So what I can do is call this like A. And I'm going to say a squared plus 10 squared equals 25 squared. And then let's find what a is quickly. 25 squared is 625. And I can subtract this. So a squared is 525. And then to find out what a is, just square root that. That's going to be 22.9. So this side right here is 22.9. So now that I know that, I can use that to write Pythagorean theorem with this triangle. So I can say 22.9 squared plus x squared equals 28 squared. So I'm going to have to do the process again, but now with the sides of the upper triangle. So let's go ahead and simplify this. 22.9 squared is going to be 524.41. And then 28 squared is going to be 784. So let's go ahead and move this over to the other side. And let's do some subtraction. So when we subtract these numbers, what we'll end up with is 259.59, and then we need to square root that in order to know what x is. So that would be about 16.1. So you just have to be able to see how there's different right triangles and well, they share a side. So if I know the lengths of these, I can use that to find this shared side, and then I can use that to help me find the other leg. Number 9 is also more complicated. At first, we need to know what this measures so that we can find x. If we know that these are congruent, we know that this is 20, right? But what is this right here? Well, if all of this is 40 and this appears 26, we can subtract those two numbers, and that's going to be like this and this. So 40 minus 26 is going to be 14. And so if we split 14 in two, that means each of these is going to be 7. Let me use a different color. This side is 7, and this side is 7. So what I can do now is set up a Pythagorean theorem using the 7. 7 squared plus x squared equals 20 squared. And now we just need to solve this for x. So 7 squared is 49. 20 squared is 400. Let's subtract this 49. That's going to be 351. And then if I square root that, I'm going to be left with 18.7. So that's our answer there. So there's going to be some word problems that you'll have to do that just require you to draw a picture and find out what is the missing side that you need to solve for and use the Pythagorean theorem in order to calculate what that side is. So like number 10, it says a roofer leaned a 16-foot ladder against a house. So I guess I'll try to draw a house, and then I can draw a ladder next to it as best as I can. And it also says if the base of the ladder is 5 feet from the house, so from here to here, that's 5 feet. How high up the house does the ladder reach? So basically it's asking, what is this length? And we know that the ladder itself is 16 feet long. So hopefully you can see how we're going to set this up. We're just going to say x squared plus 5 squared equals 16 squared. Because really what we're dealing with here is a right triangle. So we can just apply the Pythagorean theorem to this problem. So let's go ahead and solve this. This is going to be 25. 16 squared is 256. I can subtract this. And that's 231. So in order to find what x is, I need to square root that. So the square root of 231 is 15.2. And we're talking in terms of feet, so I'm going to add that as my unit. And there we go. Number 11 says Kurt is building a rectangular deck. So let's draw this rectangle to represent the deck. If the dimensions of the deck are 10 feet by 23 feet, so this is 10 and this is 23, what is the length of the diagonal of the deck? So how can we find out what this is? Well, basically we know this is 23, right? And the diagonal is, in this case, is like the hypotenuse. So what I can do is set up an equation that's like 10 squared plus 23 squared equals c squared. I can call this c. So now I just need to solve for c. 10 squared is 100, and then 23 squared is 529. I'm going to add these two together, so this is 629 equals c squared, and then I need to square root that to get c. So the square root of 629 is 25.1, and again, we're talking in terms of feet, so I want to include that in my answer. All right, so number 12 says that Ashley jogged 3.4 miles east, then 5.7 miles south. How far is Ashley from her starting point? So let's say this is our starting point. If she jogged 3.4 miles east, that's like she went, if we're looking at a map, it's like she went to the right. So that's 3.4. And then she went south, which is like she went downwards. That's 5.7. And we want to know how far is she from her starting point. So this is like our x. So we can just do the same thing that we did in the previous problem. We can do 3.4 squared plus 5.7 squared equals x squared. 3.4 squared, we would need to type that in, and 5.7 squared is 32.49. Let's add these two together, so that's going to give us 44.05. And then let's go ahead and find the square root, because that's going to be our x. So 6.6 is what we get there. And this time our unit is miles. So I'm going to write miles in our answer. Number 13 says that a 31-foot support wire is attached from the top of a 25-foot telephone pole to a point on the ground. How far from the pole's base does the wire meet the ground? So let's see if we can visualize this. We know that there's a 25-foot telephone pole, and there's like a support wire, meaning something that is attached from the top of the pole to the floor or the ground, and that's 31 feet long. And the question is asking how far from the pole's base, right here, does the wire meet the ground? So this is like our x. So 31 is our hypotenuse, so that means that's going to be the one that's by itself. So 25 squared plus x squared equals 31 squared. 25 squared is 625. 31 squared is 961. If I subtract this, I'll have 336, and then I need to square root that. So x is equal to 18.3 feet. Okay, and there's one other concept that's important with the Pythagorean theorem. That's the converse, or in this class, the converse just means kind of like the opposite or in reverse, because this will help us classify triangles. So say we're given a triangle and we know the three side lengths, A, B, and C, are just like variables for the side lengths. So if C squared is equal to A squared plus B squared, if you put them in that order and then you square each of them, and then this turns out to be equal to A squared plus B squared, then you know that you're dealing with a right triangle. If, on the other hand, C squared is greater than A squared plus B squared, then the triangle isn't a right triangle, it's actually an obtuse triangle. This means that when you plug them all into that formula, this number on the left is bigger than the number that you end up with over here. And lastly, if C squared is less than A squared plus B squared, then we know the triangle is acute. So one tip to remember is always keep C squared on the left side to avoid confusion when classifying, because then we can always just refer to this and just look at it and decide, okay, it's an obtuse triangle, or it's a right triangle, or an acute triangle, whatever the case may be. So here's how we're going to do some of these problems. First, we determine if the three side lengths could form a triangle. The sum of the two smaller sides must be greater than the third side. So in a triangle, that always has to be the case. And if that doesn't come out to be true, then you can't actually form a triangle with those side measurements. So I'll do some examples to further explain that. But say, yes, we can form a triangle, then we need to classify it further as acute, obtuse, or right, based on what we just talked about, the Pythagorean theorem converse. So let's see if out of these three side lengths, we could actually make a triangle. So in order to do that, the sum of the two smaller sides, so like this, must be greater than the third side. So 3 plus 7, is that greater than 9? Well, 3 plus 7 is 10, and 10 is greater than 9. So yes, we can form a triangle. And now what we're going to do is plug these numbers into this, the Pythagorean theorem. C squared is like the biggest one, so 9 is our C. So I'm going to say 9 squared. And instead of putting equals, I'm just going to put the colons because we don't know if it's going to be equal. It might be greater than, it might be less than everything that's on the other side. So I'm just going to put that there for now. And then I'm going to do 3 squared plus 7 squared. So let's go ahead and simplify this. 9 squared, or 9 times 9 is 81. 3 squared is 9, and 7 squared is 49. If I add together the things on the right, 9 plus 49, I get 58. So 81 is actually greater than 58. And if c squared is greater than a squared plus b squared, we have an obtuse triangle, which means that's the box that we should check off here. Obtuse. So let's go ahead and start by, on number 2, by checking to see if we can make a triangle. Let's add together the two smaller ones. So 20 plus 21, is that greater than 29? Well, 20 plus 21 would be 41. 41 is greater than 29, so yes, we can make a triangle out of this. And then let's plug it into the formula. So I'm going to say 29 squared and put that on the left because that would be my hypotenuse. And then 20 squared plus 21 squared is going to go on the right. So 29 squared is 841. And 20 squared plus 21 squared, we could do it like how we did over here, or we could really just type all of this into our calculators and see what that is right away. If you do that, 20 squared plus 21 squared should give you 841. So these are ended up being equal, which means it's a right triangle. So I'm going to check that off here. So let's keep going with number 3. So I'm going to take my two smaller sides, 4 plus 11, and see, is that greater than 16? Well, 4 plus 11 is 15. 15 isn't greater than 16. It's smaller. So this is actually not a triangle. We wouldn't be able to make a triangle out of these side lengths. So that's what we're going to check off here. Let's try number 4. Our two smaller sides are 17 and 17. When we add those two together, is that greater than 22? It's pretty clear that yes, this would make a triangle. So let's go ahead and see what type of triangle it would be. So 22 squared, and then compare that to 17 squared plus 17 squared. 22 squared is 484. And then 17 squared plus 17 squared is 578. So this actually ends up being larger. And if c squared is less than a squared plus b squared, like here, we have an acute triangle. So that's what we're going to check off here, right there. Okay, let's look at number 5. So let's take our two smaller sides and see if we can make a triangle out of this. 18 plus 24, that's definitely going to be more than 30. So we can say, yes, that is a triangle. And then let's plug everything in. So 30 squared compared to 18 squared plus 24 squared. Well, I know that 30 squared is 900. And 18 squared plus 24 squared turns out to be 900 as well. So since these are equal, this is a right triangle that we're dealing with. Let's check to see if number 6 can make a triangle. I need to add 8 and 15, since those are my smaller sides, and see if they're greater than 23. Well, 8 plus 15 is actually exactly 23, and it needs to be greater than 23. So this is one of those cases where, again, we cannot make a triangle out of these sides because the smaller sides aren't bigger than 23 when they're added together. So we're just going to say not a triangle. Let's check number 7. 31 and 35. If we add these two together, are we going to get more than 39? Yes, that's pretty clear. So now let's see what kind of triangle it would be. Let's take 31 squared, or 39 squared, and then compare that to 31 plus 35 squared. Well, 39 squared is 1,521. And then if you just type the rest in your calculator, 31 squared plus 35 squared, that's going to give you 2,186, which is greater than 1,521. So our c squared ended up being less than 2186. And if c squared is less than, then you have an acute triangle. So this is an acute triangle. And then let's look at number 8. These are our smaller sides, so let's add these two together. 11 plus 19, is that greater than 28? Well, 11 plus 19 is 30. 30 is greater than 28. So yes, this does make a triangle. Let's see what kind. 28 squared compared to 11 squared plus 19 squared. Well, 28 squared is 784. And then 11 squared plus 19 squared, if you type that all in, you would get 482. So 784 is greater in this instance. And if c squared is greater, like that, we end up with an obtuse triangle. So that's what we need to check off here. And that's it for the lesson.